Welcome guys. It's been a long day making a solution from LeetCode on top interview 150 questions. Welcome to my channel LogicBytesbyAK. Today we are checking out the fourth problem, which is remove duplicates from sorted array. Now let's go into the question. So, the given description is given an integer array nums sorted in non-decreasing order. It means it is given in increasing order. And remove some duplicates such that each unique element appears at most twice, which means the element can repeat at maximum of two times, right? So the relative order of the element should be kept the same, since it is impossible to change the length of array in some languages. You must instead have the result be placed in the first part of the array of nums. So here we do not use any extra space, and we should replace our result array with the nums array, right? So we have to modify the input array itself. So more formally, if there are k elements after removing duplicates, then the first k elements of the nums should hold the final result, and it does not matter what you leave beyond the first k elements, and return k after placing the final result in the first k slots of nums, right? So do not allocate any extra space for another array. You must do this by modifying the input array in place with order of one extra memory. So as I mentioned before, we should not create or use any another array, so we should modify the given input array itself. And we have to return number of such valid elements that can repeat at max twice, right? So we have to return 5 and we have to modify the array itself. Let's understand this and find a solution in more detailed way by taking one example. So let's take this example. So guys, find a solution for this question with these examples. So the given input array is nums, right? So and we have to modify that nums, and with element can occurs at max twice, right? So here there are two zeros, and we should these are the valid elements, right? So here the one repeated four times, and it should be suppressed to twice, and after once we have a two which is occurred at once and three occurred twice. So the result should be 0, 0, 1, 1, 2, 3, 3, right? So what we are doing here, so initially the first two elements, if they are same or different, that doesn't change, right? So if we have one value or two value, if they both are same elements or different elements, it didn't matter, right? So the first two elements are definitely valid elements, right? So from index 2, we start finding the solution. So when you are at index 2, let's say, so let's take a pointer I which iterates from third element, and what we have to do, we should check that it should not be equal to the previous two, right? So 1 is not equal to 0 and 0. So 1 will become a valid element. So what you are doing for every I element, we are checking. Yeah, let's see this. So for every I element, what we are doing, we are checking the previous two, right? So it means here one is a, wait a minute. Yeah. Here one is not equal to I minus 1 and I minus 2. So what we will do, we place this 1 and we move our current pointer to next, right? So let's go to the next pointer, which is this one. it goes to, sorry. Now our current pointer moves to next, and our previous two pointers also moves to next, right? So our current pointer I, which holds the value 1, and it is not equal to both of them, right? So if it is equal to both of them, then it is not equal, right? So we also consider this as a valid index. So we move our pointers to next. So we move our current pointer to next, and our previous two pointers. Sorry, we move our previous two pointers to this. So when our current pointer, just a minute please. When our current pointer value is equal to the both of them, it means that we should not consider this element, right? So what we will do, we will just skip this iteration and we go to the next one, right? So we move only our, let's take it. We move our current index. So the current index will holds the value 1. And what we will do, we will check it again here, right? So the current index value holds 1 and the previous two values holds 1, so which is equal to both previous array. And we do not consider this current index. So we'll go to the next, and these are not considered, right? We did not place it in the array. So, so next, by going to the next pointer, which holds the value 2, and it is not equal to the previous both arrays, right? So what we will do, we will consider this number and we move our previous pointers, right? So what will be, firstly we move our current pointer to the next by this, and we have to move our two previous pointers, right? So which one pointer will be like, we take one, yeah. Now our previous pointer will be here, and this previous pointer will move to this one, right? So we got 3 in our current pointer I, and in previous both arrays we got 1 and 2, which means if 3 is not equal to 1 and 2. So we consider this as our answer. And we move the next current value to the next, and we update these previous two, right? Which is here, and this also to here. So here a 3 is not equal to both of them. It means we can consider this as our answer. So at final, what will be the resultant array? We consider 0 and another 0, 1, 1, 2, 3, 3. If you can observe, every element, repeated at max twice, right? No element repeated more than twice. So this will be our array. Now let's code it. So firstly, we don't need any new array, right? We don't need any another array. So, so let's take n equal to nums dot length. So if the n value is less than 3, it means it can contain one element of two elements. And if they are same or different, it doesn't matter, right? You don't have to do nothing. You just return n. That's it. And Or else, so now what we do, we iterate from second element, right? For int I equal to 2, I less than, so I less than n, I plus plus. What we will do, if our current value, right? So current value, what will be current value? Index I, right? So nums of I is, let's take if nums of I is equal to, let's take a true variables which holds the previous two elements, which is into p1 equal to nums of 0, p2 equal to nums of 1, right? So if it is equal to both of them, we do not consider activity. And nums of I equal to p2, we continue, right? We skip that iteration, continue. Or else, what we will do, we can store, and it seems, and also we need a pointer array, right? So let's take uh, let's take not the elements, let's take these are indices. So let's p1 will be 0 and p2 will be 1, and if array of p1 nums of p1 equal to nums of 5, and nums of p2 equal to nums of y, it means the current element I is equal to the previous two elements, that will skip the iteration. Or else what we can do, we can store, at which position we store at uh, p2 next position, right? So if you consider here, our p2 pointer is here, p2, and this pointer is p1, right? So if I is valid, where it will be stored at P2 plus, right? We will store next to P2 index, right? So nums of P2 plus 1, sorry, plus 1 equal to nums of I. And after that, we have to move the pointers, right? Each pointer moves by one pointer, right? So what we can do, P2 plus plus, P1 plus plus. And we have to calculate number of valid elements, right, which is k. Initial k value will be 2. So for every else statement, we increment k by 1, and at last we can return k. So let me compile this. I hope you are clear with this code. Yeah, it accepts this cases. It was good. And if you observe, guys, what is the, I mean, there is a common point between P1 and P2, right? So we don't need two variables. P2 is what? P1 next index, right? So what we can do, instead of P1, P2, we can take an index value variable which whole solution is 0. And if nums of I is equal to index, or P2 is what? Index plus 1, right? So what we can do next, we increment IDX plus. I hope this was the correct IDX plus 1. So let me run it again. Oh, it goes wrong somewhere. Wait a minute. Yeah, here IDX plus 1 is P2, right? We have to store next to P2, so we increment it by twice. So run it again. accepted and I submit again. Now let's check the complexity. It will be order of n. I think. We are just doing a linear iteration. The space will be order of one. We just I declared the three variables. So that's it, guys. That's it for today's lecture, and we have to solve today's problem of the day, which is hard problem on dynamic programming. So see you in that lecture video. So if you have any doubts or if you have any suggestions for me to improve my communications or way of teaching, you can comment down below. So I'll check the comments. So please do share this video if you like the content and share it to your friends. And bye. See you in the next video.